Hi and welcome to a video from Kirby Maths which is about converting recurring decimals into fractions. Now there are two types of numbers in maths. There are rational numbers, and rational means that you can write it as a fraction. And that is most numbers. You can write most numbers as a fraction. And irrational, so irrational are numbers which cannot be written as a fraction, and that includes numbers like pi, which is a very long decimal and it never recurs and it just goes on and on forever, so we couldn't ever write that as a fraction. But what we're going to look at today is converting recurring decimals, so some quite horrible numbers, into fractions and show that they are actually rational numbers. So let's start off with a number that we can know as a fraction, and that is 0.3 recurring. So if we are going to convert 0.3 recurring into a fraction, I'm going to show you the method, and hopefully you already know that 0.3 recurring is a third, so we will end up with our answer being 1/3. So the way we do this is we introduce some algebra and we say that x is equal to the recurring decimal 0.33333, and it's handy to write out a few of the recurring bits for the matching up method, which will become clear in a second. If we times both sides of this equation by 10, on this side we get 10x, and on this side we get 3.33333. And you can see here that the decimal places on each one match up. So what happens if we subtract one from the other? The recurring decimal part is going to cancel out. So if we subtract these two, 10x take away 1x would leave me with 9x. 3.3333 take away 0.3333 would just leave us with 3. Divide both sides by 9, so we would have x is equal to 3/9, and then cancel that down. X is equal to 1/3. So we have changed our recurring decimal into a fraction. We're going to use a similar method for something that recurs in a bit of a longer sequence. So if we look at this one, convert 0.27 recurring into a fraction. This time we've got the 2 and the 7 recurring. So we start off with our algebra. X is equal to 0.272727, and so on. Times it by 10. 10x equals 2.727272. But you can see now that the decimal places do not match up with each other. So if we subtracted one from the other, they would not disappear. You would still have a recurring decimal. Let's times both of them by 10 again. So this times it would be 100x is equal to 27.272727. And now you can see that if we look at the x on its own and the 100x, the decimal places match up with one another. That means when we subtract them, they're going to disappear. So we're going to have 100x take away 1x, which would leave us with 99x, and then 27.272727 take away 0.272727 would just leave us with 27. Divide both sides by 99, and x is equal to 27/99. Now you can leave it like that if you like, or in this case 3's will go into the top and the bottom, won't they? So 3 9s are 27, and 9, that's 33, and then 3's will go again, so that is 3/11. So the most simple form in which our recurring decimal 0.27 recurring is going to be able to be written is 3/11. Okay, right, if we go on to a recurring decimal which has perhaps just one part to it recurring, so a number first of all, so let's just keep this all up here. I've got 4 of these to show you, so we'll go on to the third one now. And this time I'm going to convert 0.23, and this time it's just the 3 that recurs. So again, we go back to our algebra. X is equal to 0.2, and then it's just the 3 that recurs. 10x, I don't think is going to help us in, oh, it might do actually, is going to be 2.3333, and so on. They're not matching up though, because this 2 here doesn't match up with this 3 here. If I try 100x, I get 23.3333, and you can see now that actually my 1x isn't helpful, but here the 10x and the 100x, the decimal bits match up. So if we subtract these two numbers, so 100 take away 10 is 90x, and 23 take away 2 is 21. Divide by 90, x is equal to 21 over 90. And again, we could cancel this down, couldn't we? Because 3 goes into the top and to the bottom. So 3 7s are 21, and this would be 30. So 7 over 30 would be our final answer for this one. And finally, if you have a bit of a longer recurring number, it's exactly the same method. You just might have to times by 10 or 100 or 1,000. So if I had something like this, 0.1234, and it was, the repeating pattern was 1 2 3 4 1 2 3 4. Write down my x is equal to 0.1234 1 2 3 4 1 2 3 4. So we're looking for that pattern to repeat. 10x isn't going to help us because that would just make it 1.234. 100x isn't going to help us. 1 2 3 2. 1000x isn't going to help us. We're going to have to times by 10,000. So then we would have 10,000x is equal to 1234.1234. And you can see now that the decimal part here matches up with the decimal part here. So if we subtract those two from each other, so 10,000x take away 1x is going to be 9,999x, and that's equal to 1 2 3 4, and then x is equal to 1 2 3 4 over 9,999. Okay, now this could be on a calculator paper or a non-calculator paper. If it's on a calculator paper, it would probably be a show that this decimal can be written as this fraction. If it's on a non-calculator paper, then you would probably be asked to write it in its most simple form, which would mean doing some cancelling. Thanks for watching.